In this problem, we are given the following diagram. We are told that the voltage across the terminals of the 5 microfarad capacitor is 30 cosine 4000 t plus 25 degrees. This 30 is going to be our V max, this 4000 is our omega, and this 25 degrees is our theta or phase angle, and this is in voltages. First thing we're going to do is calculate the capacitive reactance. For this, we can look to the notes linked below the like button in the description in section 9.4, V-I relationship for a capacitor. For this formula, we know that our x of c is equal to -1 divided by our omega times our capacitance, which is c. If we plug this into a calculator, we are going to get a -1 divided by our omega, which we know to be 4000 for this case, times our 5, because this is our capacitance. However, we want to measure our capacitance in just farads, not microfarads. So what we're going to have to do is multiply this by a 10 to the -6, and this will get rid of the micro and leave us just with farads. And for this, we are going to get a -50 ohms as our answer. Now we need to calculate the impedance of the capacitor. It's going to be a similar formula. We have our Z of C is equal to, and now we're just going to have a -J divided by our W times C. Well, we know that this is going to give us the same exact thing as this. The only difference is that we have a J in here now. So our answer is going to have a J in it. Now in the question, it gives us a J right here. So we know that our answer is just going to be a -50 ohms. That is the answer for part B. Now we're going to look at part C, where we need to calculate the phasor current I. For this, we are going to use this formula. It can also be found linked in the description below the like button, and it is that our current is equal to J times our omega times our capacitance times our voltage. This should be V max, not just voltage. And then we have our angle with our theta plus 90 degrees. So now we can plug everything into here. We're going to say that our I is equal to our J. However, the J is not important here. In fact, the J is so unimportant here, I'm actually going to cross it out of this and rewrite the note so there's no J in here. It's really quite confusing if we have a J in here, so we can just totally forget about that. So instead of a J, we're just going to have our omega, which we know to be 4000, times our capacitance, which we know to be 5, and this is in microfarad, so it has to be 10 to the -6, times our V max. Now our V max is this right here, whatever number is in front of our cosine. So we're going to multiply this by 30, and then this will all be our magnitude. The next part we have is our angle right here. We know that our angle is 25 degrees, so we're just going to add it to our 90 degrees. And this is going to give us an angle of 115 degrees. So our magnitude here is 0.6. And that is the answer for part C. Now we need to write a steady state expression for our I of t. Well, we are given our magnitude, and we know that our Vm, which is V max, is equivalent to our magnitude. So this is just going to be 0.6. We know that our degrees right here is equivalent to this degrees we found. So we're going to have 115 here. And our omega does not change, so it's going to be the same omega right here. That means we're going to have a 4000 in here. And that is how you would go about solving this problem. If you want more problems like this, there's a playlist in the description below, as well as notes that cover this entire coursework.